if we wanted the area from A to B and part of it was below the x-axis and part of it was above, then you would do f of x dx equals area above the x-axis minus the area below, because this value here would be a positive value. Oops, forgot to grab a pen. This would be a positive value, and this would be a negative value, and we know that two negatives will make a positive, and we would get our area to add up. Now later on, I will show you this again, so I don't want you guys going, how am I supposed to remember this? Actually, this one might be a little bit easier. If you're looking for the area of A to B of f of x, sometimes this is a little bit easier to do, will be absolute value of the area above plus, because two negatives make a positive, the absolute value of the area below. Now the reason I say this one's kind of nicer is you don't have to worry about which one's above or below. You just do the absolute value of both, because guess what? If it's positive, who cares? It's still positive. It's that getting that negative one to be positive. But we'll talk about more about that one later on. Okay, so the second theorem you guys are going to get is the integral of a constant. F of x equals c. Remember those constants? I have 2x, I take the derivative, I get 2. Well, if you take the value on this one, so f of x equals c, just some constant, where c is a constant on the closed interval of a to b, then the integral of a to b f of x dx equals, they're showing you it's going to be a to b of c dx, because c is some constant, will give you, in the end, the answer is just simply c times b minus a. Anyways, you're going to get a rectangle. So, and then they're showing you what it will look like above or below the x-axis. So this one here, you guys are going to have, so let's just throw numbers out there. Let's say that A equals 1, B equals 4, and C equals 2. Well, then according to this, you would get 1 to 4 of 2 dx. You're like, all right, cool. Well, according to our theorem, the answer in the end would be 2 times 4 minus 1, or simply 2 times 3, or 6. Okay, so let's look at what they're talking about over here. I'm still going to use the same values, 1 to 4. And then this one here is going to be negative 2 instead of positive 2. And if I plugged it into this, what they were talking about, it would be negative, and then 1 to 4 of 2 dx. Which means in the end, the answer is negative 2 times 4 minus 1, and you're going to get a negative 6 out of that one instead of a positive 6. But if we go back to the page before to find the area, like if I had both of those, then at that point what I would be doing is I would be subtracting, so it would be 6 minus the negative 6. Okay, that's why we're subtracting. We'll subtract the negative off because 2 negatives make a positive. So let's see where we're going with this. So revisiting the train problem, this train problem, I don't remember where it is. It was probably in the book, or it's in something I used to use, or I don't know. Anyways, in algebra, you guys would figure this one out really, really quick, because in all reality, we're going to be using the distance equals rate times time. In the end, that's what we're going to be doing. So a train moves along a track at a steady 75 miles per hour from 7 to 9, expresses total distance traveled as an integral, and then evaluate that integral using the last theorem. So our integral is 9 to 7, so this would be our A and this would be our B, 9 to 7. So, I'm sorry, yeah, 7 to 9, 9 to 7, 7 to 9. Our constant is the miles per hour, so 75 dx. And this is when I get to tell you guys that this is a velocity value. What you threw in is a velocity, and so you're really looking for the position. How far did it travel? So according to that last theorem, our answer is the constant, 75, times b minus a, remember, it's A to B. So this is going to be 9 to 7, which is going to give us 75 times 2, or 150 miles. This is what I mean by we were using the distance equals rate times time. Rate, 75 miles per hour. Time, 2 hours. 7 to 9, 2 hours. If I travel 75 miles an hour for 2 hours, I'm going to move 150 miles. So don't know where we started at, but we know where we ended 150 miles later. Distance equals rate times time is really the only thing that's going on with regards to this one. We're looking for position. If it's a constant, you're going to be going for the position because you've got initial velocity going on. Okay, so let's try the problem again. Find the distance traveled by a train moving at 87 miles per hour from 8 to 11. So again, 8 to 11, 87 miles per hour dx is going to give us 87 times 11 minus 8, or 87 times 3, and you put that lovely stuff into a calculator, or write it to the side, and you get 261 miles. So the train traveled from 8 o'clock to 11 o'clock. The train traveled 261 miles. Distance. All right. So this one here, what I would like you guys to do is to pause the video and calculate this one and then double check the answer. I'm going to do one of those wait 3 seconds and then let you guys work through the problem. That way, you don't see what I'm writing. Well, I guess I waited that 3 seconds. So pause the video, try the problem, and then start it back up and I'll work through it. So we're going to do the integral here. Okay, we've got 25 gallons per minute, so 25 dx per minute during the first hour. And we have 60 minutes equals 1 hour. So our limits of integration is going to be from the time it started until the 1 hour was over, 60 minutes later. So this is what you should have got when you set up your derivative or your integral. And so the answer in the end would be 25 times 60 minus 0, or 25 times 60. Again, put that lovely thing into a calculator and you get 1,500 gallons. Okay, so if you wrote a sentence on this one, it says find the output from a pump producing 25 gallons per minute during the first hour of its operation. During the first hour of operation, the pump produced 1,500 gallons, whatever it was producing. It produced 1,500 gallons in that first hour. Okay. How did you guys do on that one? Okay, we only have a few things left. Now, we've already covered section 5.5, so you guys already know how to throw these into the calculator. Only thing I have to say about this one is be sure you are in radian mode. And then for those of you who missed it or didn't watch the video and wasn't in class, those kind of things, to put this in a calculator, you would do second. Now this is for an 84, TI-84, second window, and then 4. And then it will actually set this up. It will give you a box for this. It will give you a box for this. It will give you a box for this. And it will give you a box for this. Because they're going to be asking you what variable are you using. So if you have an 83, not sure, you're going to go to math. I think you might arrow over 1. I don't know how many people have 83s, but that doesn't mean next year I won't have somebody with an 83. Math, and it's like the 9th one down. And so you would get it in INT, and then you would put in the function x, sine of x, comma, and then the variable you're using, anyways, with respect to x, comma, and then your a value, -1, comma, and then your b value, 2. Because you're telling it, I want the value of the derivative, of the integral of x, the x sine of x, with respect to x, from -1 to 2. You gotta be communicative, gotta be able to tell the calculator what you're doing. So we throw this baby into the calculator, and you are going to get 2.0427. And remember, on the AP test, you have to be either give the 4 decimal places, anyways, you have to be corrected through the first 3. So if you round, 2.043. Now, they will accept, I'll let you know, they will accept 2.042. So if you're afraid of rounding, don't. It is that simple. Okay, so the next one, really you guys are going to just be putting things into the calculator and seeing what you get. So this one is 0 to 1, 4 over 1 plus x squared dx. Fill this into the calculator, you get 3.1415. And if you rounded, you would give either 3.141 or 3.142. And if any of you guys are looking at this going, is the answer pi? Yes, it is. Because this guy here, if I wrote it this way, 4 times 1 over 1 plus x squared, and you know this is a derivative of something, you guys should recognize that as being the arctangent. We'll talk about that one more later. Okay, but it does help if you can look at something going, oh, hey, that's a derivative. Yes, it's very handy if you can give us that. Okay, the next one, they're wanting the value of 0 to 5 e to the negative x squared. So you plug that baby into the calculator, and you get 0.8862. You can use that as the answer, or 0.886. Simple. And then we have the next one's going, what about if I'm integrating a discontinuous function? Now the calculator is pretty smart and will catch on to the fact that at a particular point, it's not continuous, but it can still give you answers, because this may not be a continuous function as a derivative, but when you do the antiderivative, it is. This is also something to point out to you, that it's very difficult to do the derivative of absolute value of x. There it is. Absolute value of x, derivative, absolute value of x over x. So if you see absolute value of x over x, you can go, hey, that's just absolute value of x. And then you know what the function is. And at that point, you can figure things out quite quickly. So on this one, if I throw it in the calculator as is, I get an answer of 1. We're not doing area. Nowhere does it say find the area. We're not finding the area. It's asking you to integrate a discontinuous function. All those others that we just did, nowhere did it ask us to find the positive or negative version of the answer. They just asked us to find the answer. But this one here, more proper way. Now, if you were doing this without a calculator, you probably could have still done this one. But normally what we would have done is done an integral of -1 to 0, because that's where it's discontinuous. You can't put a 0 in the denominator here, of absolute value of x over x plus, oops, don't forget dx, plus the integral of 0 to 2, absolute value of x over x dx. And that's going to give you an answer of 1 as well. So I want you guys to go, all right. Actually, when I put it in -1 to 2, the absolute value of x dx, I got 1.0000, lots of zeros, with some number behind it. When I put it in the second way, I got exactly 1. So go figure. But be careful on these ones. Normally, you would have to break it out where it's not where it is discontinuous, because one of the values is negative and one of the values is positive. By the way, this is your -1. Because from -1 to 0, this guy's always positive, but this guy's going to be negative. And that is why it's going to be negative on this side, positive on this side. Okay, I think that is it for us. So, like I said, a little bit shorter video, even though it's still 15 minutes, a little shorter. There you guys go. You're set to do all of the homework and have fun at it. Good luck.